All right, 4.1, question number 1, okay? And what it wants you to do is find extreme values. And extreme values are maxes and mins. Okay? This is what we need to find. And on that very first question, they give you this guy right here. They give you an XY axis. And they give you a graph that looks like this. And they tell us that this is the point -2, this is the point +2, and this is the point 2. This is 2 on the y-axis. We'll make that guy taller. Okay. Oh. So what we're going to do is, in order to find the extreme values, we want to find the maximums and the minimums. Well, check your endpoints. Anytime you're going to find maxes or mins, you want to check your endpoints. And that's the first place to always start. Okay? So our endpoints on this one, check endpoints. So our endpoints on this one are at -2 and 2. Always check your endpoints. They may or may not be maximums or minimums, but you always check them out of habit. Well, if you look at our graph, we've got an endpoint here, we've got an endpoint here, and guess what? These guys are minimums. So there's a minimum at the point 2, 0, and there's a minimum at the point -2, 0. Okay? And then the other thing that we need to do is find the maximum. And the maximum for this particular guy is way up here. And this is at the point 0, 2. And these are your extreme values on this question. Like, that's it. That's all you have to do. Okay? So don't make it harder than it is. The harder stuff is coming. But this really is all there is to finding max and mins and extreme values. All right, so with question 7, what we want to do is we want to check for the extreme values. Okay, we want to check for extreme values, and we want to talk about where they occur in relation to the extreme value theorem, which says if you have a closed interval, you have a maximum or a minimum. So the first thing that we need to figure out on this guy is what interval are we on? What interval are we using? And if you'll notice, the endpoints here, the endpoints are open. And so if I have open endpoints like this, then that means I'm on an open interval from A to B. Since I'm on an open interval from A to B, I cannot check the endpoints. And the reason is the endpoints are not included in my interval. And since the endpoints are not included in my interval, I can get really, really close to them, but cannot touch them. So because of that reason, I cannot check those points. However, I do have something going on up here, which would be my what? An absolute max. So I've got this absolute max that occurs when x equals c. Now we don't know what the value is, we weren't told, but we do know that I do have an absolute maximum value. However, on this particular problem, since I have an open interval, I cannot say for sure with certainty that I have a minimum. So on this question, your answer would be you have an absolute max when your x value equals c. Alright, so number 11 from 4.1. And what we want to do is take a function that they've given us, 1 over x plus natural log x, on the closed interval 0.5 is less than or equal to x is less than or equal to 4. And we need to use analytic methods to find the extreme values of the function on the interval and where they occur. This is where your calculus comes in. Okay? One of the things from the notes last night was if we can find the derivative of a function and set it equal to 0, then those values of x which make it equal to 0 are maximum and minimum values. So let's call this guy x negative 1 plus natural log x. So when I take the derivative, I'm going to have negative x to the negative 2 plus 1 over x. Is this a good derivative? So here's my derivative of x. Now, what we want to do is set the derivative equal to 0 or find where the derivative is undefined. Okay? So we want to find where f prime of x equals 0 or where f prime of x is undefined. Okay? In order to find zeros, I need to look in the numerator. Okay? And nothing I do in the numerator will give me 0. Would you agree? Like there's no variables up there to mess with at all. Okay? So the next thing I need to do is look in the denominator, and anywhere the denominator then is equal to 0, I'm undefined, and that's a possible max or min. Okay? So what you're going to do is take the denominator here, x squared, and set it equal to 0. So my critical point is going to be x equals 0. Okay? And then I check my endpoints, and I check my critical point in the original function, and then I can look at those guys and know if I have an absolute maximum or an absolute minimum, but all of these will give me maximum or minimum values. And so then we're just going to set up three little mini problems here. We're going to look at f of 0.5. We're going to look at f of 0. And we're going to look at f of 4. So 1 over 1/2, which is 2. 1 over 0 plus the natural log of 0, which is going to be undefined. And 1 over 4 plus the natural log of 4. Yeah, so on the back to this first guy. Plus natural log 1/2. There we go. All right, and then just look at these guys. So what's going on at 0? Can you use 0 at all? Okay, can you use 0 at all? It's undefined. We can't use it. It's not maximum or minimum. But then we can come over here and look at these other 2 points. So this guy would be 2 plus natural log of 1/2. This guy's going to be 1/4 plus natural log of 4. And we just need to figure out which one of those is bigger. So punch them in on your calculator. And 2 plus natural log of 1/2 is 1.307. And then punch in the other guy. This guy's going to be 1.636. So what do we know? We know that here is our maximum, and we know that here is our minimum. And for this particular problem, where did they occur? They occur on your endpoints. Okay? Alright, so here's what we didn't do a second ago. Solving this guy out. On this problem, we've got to add this fraction together. Okay? And when we add this fraction together, you have to get a common denominator. And I didn't do that a second ago. So what we're going to do is we're going to get this common denominator, and then we'll set that equal to 0. And so how do you get a common denominator equal to 0 to add up? You're going to multiply this side by x. And when you do that, you get -1 plus x over x squared. And so now you take that top and set it equal to 0. And when you do that, notice that a second ago, incorrectly, we get f of 0, but here we're going to get when x is equal to 1. So we can come back into this guy then, and we can change all of these values around to the correct number of 1. And 1 divided by 1 is 1. The natural log of 1 is 0. And so what you're going to end up with on this guy is 1. So he becomes our actual minimum. He becomes our absolute minimum. He becomes the absolute minimum. And our other endpoint over here just becomes a minimum, not the absolute minimum. And the reason is 1.3 is larger than 1, and 1.6 is larger than 1. And since those two things are true, then my value of 1 becomes a minimum. And then 1.3 is less than 1.6, and because of that, my 1.6 is my absolute max. Alright, so what we're doing on this one is finding the extreme values. And when you're going to find extreme values, you've got to take a derivative and set the derivative equal to 0. Okay? That's the first thing you have to do. And then and wherever we get our derivative equal to 0 or undefined, you're going to have an extreme value. And we check those points, and then we check the endpoints of our interval. Okay? And this will let us know where our extreme values are located. So the derivative of this guy is cosine x plus pi over 4 times the derivative of x plus pi over 4, which is not hard. The derivative of x is 1. The derivative of pi over 4 is 0. So basically we're just cosine of x plus pi over 4. Now what makes this question a little bit more challenging is we want to know where this is equal to 0. So you have to ask yourself, where does the cosine equal 0? At what values does the cosine equal 0? And the values where this occurs would be when x is pi over 2, or 3 pi over 2, or 5 pi. Now we're going all the way up to 7 pi, so 5 pi over 2, and 7 pi over 2. And so on our interval from 0 to 7 pi over 4, this is almost but not quite 2 pi. So we would just look at these two guys right here. Okay? And what we want to do is set the inside of the cosine equal to these measures. So what we want to go, okay, I want not cosine here. I want x plus pi over 4 to be equal to pi over 2. This will give me a 0, because whatever number I add to x, if I can make a pi over 2, the cosine of pi over 2 is 0. That's what we're interested in. The other one we're going to check out is x plus pi over 4 equals 3 pi over 2. These are the two places on the unit circle where the cosine will give us a 0. And these are the only two places. So now you're just working through a little bit of math here. Go ahead and subtract pi over 4 from both sides. And x equals, well, you can only treat these guys just like you would any other fractions. Okay? So everything needs to be the same on the bottom. And that would give us 2 pi over 4 as an equality for pi over 2. So 2 pi over 4 minus pi over 4 is pi over 4. And then on the other side, the same thing. Well, 3 pi over 2, that's like saying 6 pi over 4. Okay, it's the same thing. So 6 pi over 4 minus pi over 4 is 5 pi over 4. And if we're looking for these extreme values, what we want to do is we want to check where x is pi over 4. We want to check where x is 5 pi over 4. We also want to check where x is 0 and where x is 7 pi over 4. We have to check these 4 places to look for maximums or minimums. And so it looks like it's a horribly long process, but it should work out where it's not too painful. Okay? So we're going to check f of 0. We're going to check f of pi over 4. We're going to check f of 5 pi over 4. And we're going to check f of 7 pi over 4. And so this first guy is the sine of 0 plus pi over 4, which is the sine of pi over 4, which is square root of 2 over 2. The next guy is the sine of pi over 4 plus pi over 4. That's 2 pi. That's pi over 2. And the sine of pi over 2 is 1. And then the sine of 5 pi over 4 plus pi over 4. That's 6 pi over 4. And 6 pi over 4 is the same as 3 pi over 2. And the sine of 3 pi over 2 is negative 1. And then 7 pi over 4. Seven pi over 4 plus pi over 4 is 8 pi over 4, which is 2 pi. And the sine of 2 pi is 0. So when we're looking at this guy, when we're checking our extreme values, our max is right here. You have a maximum. And what point do you have a maximum? Pi over 4 and 1. That's your coordinate. And then we have a minimum. And where's our minimum? Right here at this guy at negative 1. And this would be a minimum at 5 pi over 4 and negative 1. And so there's the two extreme values for that guy. Section 1, number 19. We want to find extreme values. Find extreme values. Extreme. And so our function on this is 2x squared minus 8x plus 9. And so if we're going to find extreme values, we want to find the derivative and set it equal to 0, or find the derivative and find where the derivative is undefined. That's what we want to know. Okay? So take the derivative of this guy. This is going to be 4x minus 8. And then all you've got to do then is set this guy equal to 0. And when you set this guy equal to 0 and solve it out, you have 4x equals 8. And so x equals 2. And this is our critical point right here. This is our critical point. This is where our extreme value is going to happen. This is where we have a max or a min. And so on question 19, the directions say find the extreme value of the function and where it occurs. So if we graph this, if you just think about it just for a quick second, this doesn't have to be a perfect graph, but doesn't this graph, it looks like this. It's a parabola, right? Opening up, and we can tell from these two things right here that I have a parabola opening up. My critical point is at 2. So what that tells me is if I look at f of 2, the function at 2, that would be 2 times 2 squared minus 8 times 2 plus 9. So if I look at this guy, this is going to be 8 minus 16 plus 9, which is 1. So at the point 2, 1, then I have a max or a min. I have a critical point. I have an extreme value. And if you follow your rules of parabolas, then we know that this guy right here, this point, 2, 1, is going to be a minimum value. And that's all there is to it. That's all you're doing with these types of questions. Take the derivative, set it equal to 0, or find where it's undefined, and check that x value in the original function. Alright, so another problem from your homework then, question 36, we want to go for the critical points and the extreme values. And when you do this, notice there are no endpoints to check. There are no endpoints to check. So wherever we are undefined for the derivative, undefined for f prime, or 0 for f prime, these are going to be where your extreme values occur, your critical points occur. Okay, so if we take the derivative of this guy, we've got a u and we've got a v, which means that we're going to use the product rule, and that looks like u v prime plus u prime v. So don't forget this part of the calculus. So y prime is equal to the first times the derivative of the second. The derivative of x squared is 2x. The derivative of 4 is 0. Plus the derivative of the first, 2/3 x to the negative 1/3. Times the second, which is x squared minus 4. And we want to know where this is equal to 0. So what I would recommend is clean this guy up a little bit and make him pretty. So remember, if you've got 2x to the first, that's the same thing as saying x to the 3 over 3 power. So 2/3 plus 3/3 is 5/3. So this is 2x to the 5/3 plus, and then over here, x squared is the same thing as 6/3, the 6/3 power. And so I would have 2/3 times x to the 5/3, negative 1 plus 6, negative, so that'd be 5/3 power, minus 8/3 x to the negative 1/3. So that's really a nasty looking guy. Okay, we can put the first two pieces together. They have x is the same on both, so we can put these first two pieces together. So 2x plus 2/3. Remember, this is like saying 2x is the same as saying 4/3. So 4/3 plus 2/3 is, how many thirds is it? Whoops, that's 6/3, not 2/3. 4/3. So 6/3 plus 2/3 is 8/3 x to the 5/3 power minus 8 over 3x to the 1/3. And we want to set all this equal to 0. So this looks really nasty right now. What we want to do then is get a common denominator. And so the common denominator in this case, we need an x to the 1/3 over here in the denominator. And if I multiply by x to the 1/3 over here, I've got to do it also on the top. And so this will get me then 5/3 plus 1/3 is 6/3, right? Which is 2. So 8x squared minus 8 over 3x to the 1/3 power. And we want to know where that is equal to 0 or undefined. And those are going to be our critical points. And so to find the 0 part, take your numerator right here, your numerator, 8x squared minus 8, set it equal to 0. And so when x is plus or minus 1, when x is plus or minus 1, we've got critical points there. Okay? And then, to find where you're undefined, take the bottom and set it equal to 0. So this would be x to the 1/3 equals 0. And cube both sides, right? So if you cube both sides, don't forget that trick. Just like on the previous part, we square rooted. And so when I do this, x is equal to 0. So my critical points, I'm undefined. Let's look back up here. I'm undefined when x is equal to 0. I have a 0 when x is equal to plus or minus 1. Those are my critical points. Okay? So to determine the extreme values for this guy, all we would need to do then is substitute in these values we just found into our original equation. So what we're going to do is look at f of 0, f of 1, and f of negative 1. And this will give us what our extreme values are, where our maximums and minimums are located. Okay? So what have we got? We've got 0 to the 2/3 times 0 squared minus 4. So this guy is going to be negative 4. Then I've got 1 to the 2/3 times 1 squared minus 4. And that's going to be 1 times negative 3. So negative 3. And then the last guy is negative 1 to the 2/3. Negative 1 squared minus 4. And remember, 2/3 is you're squaring and cube rooting. So if we square and then cube root a negative 1, it's just going to be 1. And then a negative 1 squared is a positive 1. So this guy again will also give us negative 3. So my extreme values occur at 0, negative 4. Here's an extreme value. I have an extreme value at 1, negative 3. And I have an extreme value at negative 1, negative 3.